All right, so today we are looking at 13.2e. This example is not in the book, but it is a review a little bit of something we did in the mole unit, which is finding the empirical formula. So if we read this question, we have a mass, 4.702 grams, and we have a pure gas, and we have a volume, 1.50 liters, and we have a pressure, 150.0 kilopascals, and we also have a temperature in degrees Celsius. Now we're told that this gas is made entirely of carbon and hydrogen. So we have C something, H something, so we have a hydrocarbon. And we are also told that it is 85.63% carbon. And now we want to know the molecular formula. And I don't know if you remember what a molecular formula is. Do you remember what a molecular formula is? Yeah? Okay. So the molecular formula, just in case anyone doesn't remember, is the actual formula showing you the actual number of each atom. Actual number of each atom. But to find the molecular formula, we will first have to find the empirical formula. You remember what the empirical formula is? Yeah, it's the simplified version, the smallest whole number ratio. Yeah. Good morning. Come on in. Okay, so first we're finding the empirical formula, which is the simplest whole number ratio of atoms. So the trick to all of this is if you want to find the whole number ratio of atoms, if you can find the moles of carbon and the moles of hydrogen, you can find the ratio of one to the other. Yes? So we have actually a little rhyme that helps you remember how to find the empirical formula if you forget. And that is convert to mass. Mass to moles. Divide by small. This is the part where we're finding the ratio. This question is just on the desk right there. There's just a little extra thing. This isn't an, yeah, that one there. This is not in the actual book. Yeah. Divide by small. And times till whole. So first thing we need to do if we're going to find the moles is we need to have something we can find it from. And right now all we have is a percentage of carbon. That's not much use to us, okay? But we do know that we have 85.63% carbon. If we assume we have 100 grams, of the compound, that means that we will have 85.63 grams of carbon. Since we have 85.63% carbon in the compound. Could you figure out the grams of hydrogen, our other element in the compound? Good morning. We have a question on the desk here that you can grab. It's an empirical formula, molecular formula question. Okay. And how would we find the grams of carbon, or sorry, the grams of hydrogen? We would take 100 grams minus 85.63 grams. And I should have got my calculator. 100 minus 85.63 equals 14.37. And because I've assumed there's 100 grams, that can be, I can stick as many decimal places on that as I like, so I can keep my 4 sig figs there. Okay, so now I have my mass. So I've done the first thing. I have found the mass of each element. Second thing we want to do is we want to convert the mass to the moles of each element, because if we know the moles of each element, we can find the ratio between them. So let's do that. So we're going to find the moles of carbon, 85.63 grams of carbon times 1 mole per, we'll use the 12.01 grams from the AP periodic table. So we have 85.63 divided by 12.01, and we get 7.1299 moles of carbon. Moles of hydrogen. We have 14.37 grams of hydrogen times 1 mole per 1.008 grams. Again, is our AP value, 14.37 divided by 1.008 equals, and we get 14.256 moles of hydrogen. And we would like the ratio of carbon to hydrogen. And in fact, if you just look at that, you can probably tell what the ratio is. Can you tell what the ratio is? Yeah, it's a 1-to-2 ratio, okay? But we would actually show our work. We would say, okay, I'm now going to, so this was step 1, we found the mass. Step 2, we found the moles. Step 3, we're going to divide by the smallest amount. So we take the, step 3, sorry, we're going to divide by 7.1299. Now, just a quick question here. Could I write divided by 7.1299? Would that be okay to write this here? No, because this bit is equal to 7.1299. It is not equal to 1, which is what it would be. So you cannot do it in that one step. You could show the work down below if you wanted to, or you can show it like I've done here, okay, and we get 1. Okay, so I would get rid of that because I don't actually want that. And then I would divide by the other one by 7.1299, 7.1299, and we get 1.999, which is approximately equal to 2. So that's step 3. Find the mass, mass to mole, divide by small. And the final thing is, if we do not have whole numbers, we would have to multiply until we got whole numbers. So if we had, let's say instead of a 1-to-2 ratio, if we had a 1 to a 1.33, what would we multiply if we had a 1 to 1.33 ratio? We'd multiply by 3, okay? What if we had a 1 to 1.67 ratio? What would we multiply by? You just need to know what this fraction is. What fraction is that? That's 2/3. So you're going to multiply by 3, okay? And same thing, if you have a 0.25, you'll multiply by 4. If you have a 0.75, you will multiply by 4. So it just depends whichever fraction you have. If it's thirds, multiply by 3. Quarters, multiply by 4. Halves, multiply by 2. But we don't have any of that today, so we don't have to times till whole. We just have to go, oh, this is 1 carbon for every 2 hydrogens. So therefore, the empirical formula, the simplest whole number ratio, empirical formula is carbon, C, and we don't have to put the 1, H2. So there's nothing different here than what we did in grade 11. What we are going to do now is we are going to take this, and now we need to find the molecular formula. And the molecular formula will be some, what do we call that thing when you multiply it and you get something else? Some multiple of CH2. Might be CH2, but it could be C2H4, it could be C3H6, and we have to find out which one. How can we do that? Does anyone remember? How can we find out how many times bigger the molecular formula is than the empirical formula? You don't have to tell me from the numbers that we have, just in general. Yeah, we would divide, we would take the molecular formula mass, molar mass, and we would divide by the empirical formula, molar mass. And that would give us a value n, and then that n value, we would take CH2 and we would multiply it by n, okay? So somehow or other, we're going to have to work gases into finding our molar mass of our molecular formula, because our molar mass of the empirical formula is just going to be 1 carbon and 2 hydrogens. So we have 12.01, and we have 2 times 1.008, 2 times 1.008 equals 2.106, 12.01 plus 2.10. Did I do that right? That's not right. 2 times 1.008 equals 2.016. That looks better. 016 plus 12.01. And we get 14.026 grams per mole. So that is the empirical formula, molar mass, right there. Now we need to actually do the gas stuff. Let's go back to our question, and we will grab 1.50 liters. We have 4.702 grams. That's the mass, that's the volume. We have the pressure is equal to 150.0 kilopascals, and we have the temperature is equal to 49.8 degrees Celsius. What would we do with our temperature? Change it to Kelvin, okay? So we add how much? 273.15. If you forget that, it's always on your data sheet. So we have 49.8 plus 273.15, and we get 322.95 Kelvin. Can we find molar mass using these four pieces of information? What is the unit for molar mass? It's the grams per mole. Do we know the grams? Yes, we do. Okay, so we have our grams that we can put there. Do we know our moles? No, we don't. But if we have volume and pressure and temperature, can we find our moles? Yes, we can. And what would we use? PV equals nRT. Okay, so let's do PV equals nRT. We'll solve for n. N is equal to PV over RT. And I don't believe we have an R that uses kilopascals. So we'll have to convert kilopascals into probably atmospheres is easiest. Okay, so we have, you wouldn't get a kilopascal question on the AP exam. They don't do kilopascals because they're American. But anyway, our pressure is equal to 150 kilopascals times 1 atmosphere is equal to, and if you don't know this, it's okay. It'll either be given to you on a 101.3 kilopascals. It'll either be given to you on a test or not at all. And, well, I'm not testing you on this, so AP won't care. They won't give you this one. All right, so we have 150 divided by 101.3 is 1.48075 atmospheres. So now we take pressure, 1.48075 atmospheres, times the volume, 1.50 liters, over R, and the value for R in atmospheres is 0.08206 liter atmosphere per mole, or mole to the -1, per Kelvin, Kelvin to the -1. And then our temperature, 322.95 Kelvin. Let's see if our units actually do cancel. Atmospheres on the top cancel with atmospheres on the bottom. Liters on the top cancel with liters on the bottom. Kelvin cancels with Kelvin to the -1. And the only thing we're left with is moles to the -1 in the denominator. So if we move that to the numerator, it becomes moles. Okay? And then our numbers, times 1.5 divided by 0.08206 divided by 322.95 equals 0.08381 moles. So now we can go and we can say we want the molar mass of the molecular formula. And we know that the mass that we have is 4.702 grams. And we just calculated our moles, 0.08312. We do the division. And we get 56.102 grams per mole. Okay, now having done that, let's see what else we've got here. We now have our empirical formula mass, 14.026. So our molar mass of the molecular formula over the molar mass of the empirical formula is equal to molecular formula is here, 56.102 grams per mole, divided by the empirical formula mass, which we calculated up here, 14.026. And we hope that I have not made a mistake somewhere, because if I don't end up with a whole number, I will cry, because that will mean I have made a mistake. Divide by 14.026 equals 3.9998. That looks good. So exciting. 3.99 is very close to 4. Hurrah. Okay, and so that's our multiplier. So now we have CH2, and we're going to put a 4 there, and then so that is now going to become C4H8 is the molecular formula. So to be honest, there's nothing new in this question. It's just that maybe you've forgotten how to do empirical formula, you've had a refresher on that, and we're applying the gas stuff within there. Do one of those questions for homework. Just pick one, do one, and that's it for this week. Yeah, thank you guys. Yeah, so do one of the questions, maybe just do the first one, 13.2e, number 1, just so you don't forget. Okay. Or would you like to do these questions next week? You could do them next week in our tutorial. How busy are you right now? You can do one? Chloe, you don't look sure. You think it's okay? Okay, so do number 1, and yeah, we'll leave it there. Cool, very good. And that is, for anyone who's wondering, that is on page 23. Oh, that's an easy one though. It gives you the empirical formula. Oh, should we do a different one? Yeah, let's do number 2 instead. Do number 2 instead. That way you have to actually remember how to do it.